So this is the part we will be generating toolpaths for today. You can see that I already have my entire toolpaths setup already created. So a quick little overview of what we're gonna make. We have 4 different toolpaths. The first one is a face, and so once we click on it, we can see 1, our simulated stock, and then 2, the actual toolpath. So the face toolpath is going to face the top of our stock, flattening it down. The next toolpath is a 2D adaptive. A 2D adaptive toolpath is a very effective toolpath for rough clearing out large amounts of material. So the 2D adaptive is going to be removing most of the material outside of the perimeter of our part and also the inner pocket of our part. The next toolpath is a 3D adaptive. And the reason we need 2 different adaptive toolpaths is mainly because one's 2D and one's 3D. The 2D adaptive follows 2D lines. One way to think about it is that 2D adaptive toolpaths are for flat-bottomed pockets. So like the outer perimeter, we are removing the material down to a flat surface, same as the inner pocket. That feature has a flat horizontal face, so we only need a 2D adaptive. The 3D adaptive is what we're using to clear out the sloped portion of our material, because the feature varies in the Z direction. We need a 3D toolpath that is going to follow that face. The 4th toolpath we have is a 2D contour, and this is our finishing pass. So the previous 2 adaptive toolpaths I have set to leave stock, so that because adaptives don't give you, they're always for roughing. They're not going to give you clean faces on your material, on your part. So usually you want to set them to leave a bit of stock so that they're not bringing it to the final dimension. They bring it to a little bit oversized, and then you can combine with a 2D contour. And along all of the vertical faces, I have it doing a single lined path around, bringing the part to its final dimensions. Let's look at creating our toolpaths. I have duplicated that original part and into a new file and stripped it of all the toolpaths I created, so that we can start with a fresh slate and see how I got to that. So this is the model we will be machining. So the first thing I'm going to do is, on the top left, switch my workspace from design to manufacture. Manufacture workspace is where we will be doing all of our CAM, all of our toolpath creating. Before I actually create any toolpaths, so what I want to do is create a setup. So I click the setup button, and I am making a new setup. The main 2 functions of a setup is a way to define your stock and your work origin, your work coordinate system. So this is where we'll tell it the size of our stock, and we'll tell it where we are setting our work coordinate, our origin. So the first thing I want to do is define the orientation of my axes. So right now it has the y-axis going that way and the positive x-axis going that way. And it's going to depend on your setup, but I want the y-axis pointing that way and the x-axis pointing this positive axis going that way. So what I'm going to do is change the orientation of my work coordinate system from model orientation, which means it's just going to use whatever coordinate system I use to model my actual part, and I'm going to change it so that I can set it to a new orientation. So you can do this multiple ways. I like just using the select X and Y axes. So it's going to basically ask you to click on a line to define your x-axis and your y-axis. You could use a line on your model. You can also use your one of your actual original model axes. So that's what I'm going to do, because it's in the right. I just basically want to rotate them 90 degrees. So all I want to do is set I want this line to be my y-axis, and I want this line to be my x-axis. So what I'm going to do is I have the x-axis button selected. I'm going to click this green line. There we go. Then now it automatically moved it to the y-axis button, and I'm going to click that red line to define that as my y-axis. And there we go. And so just by looking at it, I can tell this is not the orientation I want it in. It is flipped. The immediate thing I can see is that the z-axis is pointing down. And in our CNC, the positive z goes up. So I need that z-axis flipped, but also I need that y-axis flipped. And so I can flip both of them by just clicking flip y-axis. So by clicking that little checkbox, it has flipped the y-axis, which in turn flipped the z-axis, and that is looking like what I want in my work coordinate orientations. So the next thing I do is define that point, that origin. So I have the axis pointing in the right direction, but I want to move the work origin to wherever I want it to be. So now we're going down to the origin. You can define your origin from different places. I can choose points on my stock box. So I can choose a corner or a middle point on my stock. I can choose points on my model box, which is pretty similar. I can choose a selected point, so I can literally choose any point on my model. I usually use stock box point because I'm going to have this chunk of wood sitting on my bed, and I want to define the work origin based on that, usually a corner of my stock. So in this case, I want to define my origin right there. I like doing, especially if you're cutting all the way through an object, you want to usually set your origin at the bottom of it so that you know exactly how far you're going into the bed. So I'm going to set the work origin right there. And there we go. So that's it for the work coordinate system. Now I'm going to switch to the stock tab. This is where we can define the size and position of our stock. The default mode is going to be relative size box, which fits a box around your model, and then we'll offset that box by a defined amount. So basically it'll just give you padding around your stock, around your model. So in this case, it's giving us 0.04 inches on the top and 0.04 inches around the sides. I usually don't use this because usually I have a piece of stock already at a defined dimensions, and I want to use that. So I'm going to use fixed size box. And in this mode, I can just tell it the size of my stock. So in my case, I am using a 4" by 4" by 4" cube. So I'll change the X to 4, Y to 4, and Z to 4. The next thing I'm going to do is change the position of my model. Right now it's at the center of X, center of Y, and center of Z, meaning that is going to put my model dead in the center of my stock. In my scenario, I do not want this. I want to put the bottom of my part on the bottom of my stock because I don't have to worry about machining the underside of my material. I just want it to be flat on the bottom of my stock. So I'm going to change my Z model position to offset from bottom, and then change that offset to 0. That way it is grounded flat on the bottom of my stock. And in my scenario, I want it centered in the X and Y. That's pretty much it. My setup is set up. I'm going to press OK. And so maybe in the beginning you only need one setup. You would need multiple setups if you ever wanted to have different work origins. Usually I do this if I'm flipping a part over. So I'd do the top portion and then I'd have to flip the part over and machine the other side. In that case, I would need to set a different setup with a different work origin on the other side of my stock. Now under that setup, I can go ahead and create my toolpaths, and those toolpaths will live inside of that setup. So the first toolpath I'm going to do on this part is a face. A face is going to flatten the top of my material. This is good for getting the top surface of your material ready, and also bringing down your raw stock to a more defined size, because the stock we started with is raw and we don't know exactly how high it is or how the height of our stock, and so if we face it down, we can be certain that we know exactly where the top surface of our material is. So it's a good starting point. One thing I realized is I messed up on my stock dimensions. It actually is going to be a 3" high piece of material. So I'm going to change my Z to 3. Now it's a lot better. So I'm going to select the face toolpath. And next I'm going to select my tool. We will not get into creating and adding tools to your library right now. I have my 1/2" tool selected. So I'm just going to select the tool I'm going to use for that specific toolpath and press select. Again, feeds and speeds are already defined in that tool. Later on we can go on and change the feeds later, but for now they are defined by the tool. So the next thing is our geometry tab. A lot of toolpaths are smart in that the case that you don't always have to define the geometry for them to work on. So like for face, it knows you're trying to bring the top of your stock down to the highest point. So if I actually don't select anything, that's okay. It's going to just bring the stock down to right there. So I'm going to not select any stock. Heights. Heights is a very important tab. This is how you can define how high your tool moves when it's traveling the bottom height is going to be the lowest portion that you cut into. The top height is the highest portion that is going to be cut. These are all fine for now. Passes, nothing to change in here. So we are going to need multiple depths because we are going through, not sure exactly how much material, but the maximum allowed step down is 0.8 of times your tool diameter. And so what's really cool about Fusion is that you can just type that expression into your into that category. So I could, since I'm using a 1/2 inch bit, I could type in 0.8 times 0.5, and that'll automatically do the math and set my step down to that height. Another cool thing about Fusion is that since it knows the tool I'm using, and I have defined the diameter, there's a variable called tool diameter. So I can actually start typing TOOL, and I get a bunch of parameters, a bunch of variables I can select from, and I want tool diameter. So this is very cool because if you end up changing the tool later, it will also change this. So we know it'll always be at 0.8 of our tool diameter. Now, this is only going to be a rule for this specific toolpath. Every other toolpath after this, I will have to also use this expression. One next step we can do is if we right click, we can click Edit Expression. Oh no, sorry. We already have our expression edited. We can save this as a default. So if I save this as use a default, it will default the face toolpath to always use this exact expression. So by right clicking and pressing save as user default, for me, as long as I'm logged in on my account on Fusion, it will use this expression for any face toolpath, which is very cool. Next tab, we have linking. I don't think there's anything to change in here. So we're going to press OK. You can see it generated a toolpath. And whenever we have our toolpath selected, it will show us a green stock, which is the stock we defined, and it will show us the toolpath. We can just click anywhere else to unselect it. This is a good time to show how to simulate. Simulate is a very important part in validating your toolpath. If we right click on our setup, we can simulate the setup. So that means it'll simulate any toolpaths underneath this inside of that setup. So we're in the simulate now, and we can turn on and off the stock. If we don't want to see it, we can turn on and off the tool. So if it's on, it'll actually show us our tool as we defined it. And you can click toolpath too, which will show you the toolpath as it moves. So we can go ahead and press start, and I can change the speed if I want to see a little slower. So press start again. There we go. After we've faced our part the next thing you want to do is clear out a bulk of the material, because we're going to have to remove all the material around it and inside. So what I'm going to do is go to the 2D category and select 2D adaptive clearing. "2D adaptive" is a very cool toolpath. I mentioned it earlier, but it is smart in a way in that it clears out a bunch of material without overloading the tool. We could have selected just the pocket, which is a more basic, simple pocketing strategy, but adaptive optimizes your toolpath to constantly be engaging an ideal amount of material. Anyways, so first tab, tool, it already knows it's going to keep the same tool we had last time unless we want to change it, but we are still using that same 1/2" end mill, so we're going to keep that tool. This all stays the same. Geometry, this we do need to define. We need to tell it what to clear out, and like I said, the two main things we want to clear out right now is the outside perimeter and the inner pocket. We're not going to worry about this sloped portion right now. So I'm going to define the geometry by clicking these little parameters. So I click that. It's going to put a blue shade in the blue area where it's going to clear. That's what I want. If for some reason it's flipped and it's trying to clear the inside of your loop, you can change which side of the line it's cutting on by this red arrow. By clicking that, you can flip which side of the contour you are pocketing. So I want the outside of that. I'm going to click this chain of lines right here, and that looks good. So that's it. Those are the two geometries I want to pocket. I am going to turn on rest machining. Never mind. Heights. Our heights are looking good. One cool thing about 2D adaptive and any 2D pocketing toolpath is that by default it sets the bottom height to selected contours. And this is very cool because it allows us to use multiple contours and without having them all be at the same Z height. So this pocket is going to stop right there, and this pocket is going to go all the way down to the bottom. And so by keeping on selected contours, it'll do each pocket at the right height. If I were to change this to, like, say, stock bottom, it would bring both of these straight down to the bottom, which is not what I want. So if you keep it at stock selected contours, it makes it easy to do multiple different pockets at different heights using the same toolpath. Passes. This all looks good. I do want multiple depths because, again, we can only go 0.8 times our tool diameter, so I'm going to turn on multiple depths. Always, when you're curious what something does, hover over it with your mouse, and there will 99% of the time be a very, very useful tooltip with illustrations. So our maximum roughing step down is what we're going to set to 0.8 of our tool diameter. So go ahead and select everything. 0.8 times tool diameter. And while I'm at it, I'm going to go ahead and save as user default. So this is where, and so by default, it's leaving stock to leave, which is what I want. And it's by default because most of the time when you're doing adaptive cuts, you don't want to bring it all the way down to the final dimension. You want to leave some stock so that you can come by with a finishing toolpath and finish it. In my case, I do want this. Yeah, so radial is going to be in the X and Y direction, and axial is Z. So by leaving some radial stock to leave, all of these faces are going to have an extra 0.005 inches around them, so they can come by with a finishing pass and bring them in to the right dimension. If I set axial stock to leave, it would leave some stock in this direction, which I could do that, but I don't want to come by and do that. It's not that important that this is dimensionally accurate. So I'm going to leave axial stock to 0 and have some stock to leave. Going over to linking. Everything should be good in here. This is usually where you can define basically how things move in and out of your toolpath. Like we can do lead-ins, lead-outs, ramps, but by default everything should be working fine. Usually I only end up over here to fix something that isn't going the way I want it. So press OK. Now we can see our 2D adaptive pocket, which, as you can see all these lines, it's removing the bulk of our material. And so now we can go and simulate the setup. And I always like to simulate the entire setup instead of simulating just a single toolpath, because it'll show you every toolpath in the entire setup. So again, face it. And that looks great. In the simulate interface, it will tell you if there's ever a collision. If for some reason there's ever a toolpath that causes the tool to just dive straight in to the material or come at it from the side at a fast rate, it should notify you of a collision. And you can turn on stop on collision, which will stop the simulation, pause it, showing you exactly where a collision would happen. And if there was a collision on my toolpath, you would see a little red marker. But we are good. I can even turn off toolpath if I want, give me a cleaner visual. Speed it up. And that looks great. Next, we'll go ahead and create our 3D adaptive toolpath. So I mentioned earlier that the 2D adaptive is only good for clearing out flat bottomed pockets. So like the outside and this inner pocket are all flat bottomed and 2D or 2.5D. And the 3D adaptive is what we're going to need to clear out this sloped portion. So under the 3D category, adaptive clearing, I already have the 1/2 inch end mill selected. For geometry, we are going to define our stock contours. So that's going to be these top faces. So select that. And it's going to project it downwards. It's fine. And sometimes it doesn't let you select the perimeter of the face. So what we're going to do is we're going to select one edge of it, but then we're going to click that yellow line to edit it and then we're going to select the lines that we want to use to create our closed loop. So it's set, and there we go. So they're projected downwards, but those are the two regions that we want to perform the 3D adaptive clearing on. I'm going to turn off rest machining. Heights should be good. You note that the bottom height is set to the bottom of my stock. That's fine. This is different from 2D adaptive in that it's not going to actually bring the pockets all the way down to the bottom. It's going to know that my model geometry is right there, and it'll bring the toolpath down to those exact heights. In passes, this is where we're going to again set our maximum roughing step down to 0.8 times tool diameter. Gonna save that as user default. And I don't actually want to leave stock to leave. I don't plan on coming by and doing a finishing pass on these sloped portions. Mainly because it's not worth my time because they're not dimensionally really needed, and I'm just going to come by and sand the wood myself. So I'm just going to turn off stock to leave, and it's going to now bring those lines, the cuts it's going to make down to the final dimension. And one thing to note is that it's going to be rough, so it's going to put a staircase effect on my slopes because this is a flat end mill, and it's not going to give us smooth. I could come by with preferably like a ball nose end mill and do some finishing, but it's not needed. So maximum roughing step down, 0.8 tool diameter. That's it. Linking is fine. And that looks good. We'll go ahead and simulate it. So that's what I meant by the staircase effect. Now my final toolpath is going to be my finishing toolpath. Because remember, with this 2D adaptive, I left 0.005 inches, and so I'm going to come by and bring the stock into its final dimension. So I'm going to do that with a 2D contour. And I want to, I'm basically just going to be doing this on all of the vertical faces. So these outside vertical faces and these inside vertical faces. And since this is 2D, I'm just going to select the bottom of the geometry. That's important to do. That's how, if you select the bottom of the geometry, that'll allow you to use the bottom height defined by selected contours. So that, and that's the right direction. I don't want it on the inside, I want it on the outside. And I want this inner. So that looks good. Heights. bottom height, select the contours. Passes, we're going to need multiple depths. Again, this still follows the rule of 0.8 of our tool diameter. And yeah, this would be unachievable. If I were not to have multiple depths, it would have put the tool all the way down to right here and ran a tool path in one single loop. 2D contours are not a smart tool path, and so it'll plunge the material. Since there is a little bit left on our stock, it would have plunged it straight through and ran it, which would have been very bad. So multiple depths, maximum roughing step down, 0.8 times tool diameter. And I'm using roughing step downs. It's fine. Since I'm cutting radially, not axially, that's fine. I'm going to change the safe distance. This is again, see, I'm only changing stuff and linking when there's a problem. And since it's red, that's a problem. And if I hover over it, it's telling me this warning. So I just need to follow that warning. I'm going to change this to 0.2. Looks good. One more time, I'm going to simulate it. I can also use this button right here to skip to the next operation, which is nice because I've already validated those previous toolpaths, so I don't need to watch them. So I can skip to the third toolpath, and then I'll skip to the fourth toolpath. I'll slow it down. And it is going to be kind of wasting some time over here because it is cutting in a 2D contour, so it's following this, stepping down, so there's going to be a lot of unused toolpath, but it's fine. And we can turn off the tool too. It helps us sometimes see what's being removed, if anything. Let me double check that I left stock to leave. So I didn't turn on stock to leave. So I'll turn that on. So for my 2D adaptive, I do not want axial. I just want radial. And you can play around this number. It should be a very small number. That is good enough for me. Okay, so one more time. We'll simulate. Skip to that last finishing toolpath. and play. So now we can see, this is why I like to have the tool turned off. Because for doing finishing passes, it's sometimes hard to see if you're actually removing anything. And so we pause it while it's in the middle of cutting, turn off the tool. We can obviously see it's in the process of cutting away that extra 20 thousandths we left. We can change the colorization, which is nice. I like to have it on operation, which means it'll color the face based on which operation it is. So these were blue because they were created with the 2D adaptive, but then now that they're being recut with the 2D contour, it is recoloring them to the magenta color. Now it's doing the finishing pass on the outside. And there we go. So there's our 4 toolpaths. If you want to see how long it's going to take, we can go ahead and right click on the whole setup. Machining time, about 11 minutes. And from here, I can go ahead and post-process this out. I could individually post-process each specific toolpath. In that case, I'd have to load each individual G-code file, but I can go ahead and post-process the entire setup, which means it'll run all these toolpaths in the same G-code file. So we can go ahead and right-click on that, post-process, and we're going to have to choose our post-processor. So I'm going to need Shopbot. I want Shopbot Open SBP. That's fine. I can go ahead and name it in here. So, yeah, now we get to where you want to put it. Let's just say it's right here. Use whatever naming convention you want. And then I think I'm going to have to add that .sbp. I'm not sure, but I'll just be safe and add that myself. There's my G-code.